Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 7, still on differential calculus. And then as expected, our 7.1 is saying determine f prime x from first principle if f of x is equals to x cubed plus x. Now, again, applying the trick, the first thing that we have to do is let's use our rules to find f prime x so that we already have an idea of what our final answer should be. Then this is to jump down to multiply. The coefficient would have 2x, but then remember, if we are given only the variable with an exponent of 1, then our derivative is the coefficient. So the coefficient here is 1, right? So we know as our final answer, we should have 2x plus 1. So this puts us at ease in terms of us having to solve this question. So this is x squared plus x. And then below we have the expression for x plus h. Now what this means is that where you see x, wherever you see x, you need to replace by x plus h, right? So we see the x here, we have x plus h, and then square that. And then again, we see the x, we're going to replace it by x plus h. So a lot of you just make the mistake of only putting this into one of the x's there and not the other. Wherever you see x, it means replace with that x plus h. So now when we expand this one, we know that it ends up being x squared plus 2xh, then plus h squared. Then this one will obviously just be x plus h, right? Now at this point, we can see that there are no like terms, so there's nothing that will add up there. So you only have your expression for fx plus h. Then now let's start. F prime x is equals to lim h approaching 0, and then fx plus h minus fx, like that. Then let's solve now. We have our lim h approaching 0, so equal lim h approaching 0. So we take the whole expression of fx plus h, which is x squared plus 2xh plus h squared plus x plus h minus the expression for f of x. So note when I am subtracting that, I'm putting it inside the bracket because it is an expression. It is a whole expression. So you need to be very careful of that because that's where a lot of you will be making mistakes. And then over h, right? Now at this point, we have lim h approaching 0. So let's go on, cancel those ones that cancel out. So the x squared and the x squared, then the x here, and that x will eventually cancel out. Then we are only left with 2xh plus h squared, then plus h over h. Now looking at all these three terms, we can see that there's a common factor of h. Now at this point, you can already see the trend in all of these questions. Then factor out the h. This is 2x plus h. Then if we factor out h from here, we only have the coefficient, which is 1, and then over h. Now at this point, we can see what happens. The h and the h, they divide out, and then we are left with, let's just say 2x. And then where there's h, let's just replace with the 0, which is why now I'm just getting rid of the lim h approaching 0, then plus 1. Now at this point, we say therefore our f prime x should be equals to 2x. 0 plus 1 is 1, so that's 1. And then I am confident with my solution because I have already proven it using the rules, right? So now I do not even need any memo for that. I know that I'm correct. Okay. So let's move to 7.2. 7.2 says determine f prime x if f of x is equals to 2x to the exponent of 5 minus 3x to the exponent of 4 plus 8x. So that one, easy peasy, is just a giveaway. So all you have to do now is just take the 5 multiplied by 2, that's 10. And then if you subtract 1, we know that we are left with 4. And then if you take the 4 multiplied by the negative 3, so make sure that you also include that sign there. So that's 4 multiplied by negative 3, that's negative 12, and then x to the exponent of 3. And then here we know that if we are given a variable with an exponent of 1, the derivative is the coefficient, right? So 3 marks for that. That means they are just marking 1, 2, 3. So proper. Now 7.3 says the tangent to g of x is equals to ax cubed plus 3x squared plus bx plus c has a minimum gradient. So I need you to pay attention to this, a minimum gradient. Now we did touch on the fact that if they talk about the gradient, this obviously will lead us to our g prime x, which is our first derivative. And the point negative, at the point negative 1 is to negative 7. So this minimum gradient is occurring at which point? At negative 1 is to negative 7. For which values of x will g be concave up? So they're asking about g. Okay, so now let's break this down. We need to have a gradient, but this gradient needs to be a minimum value. You will remember from the cubic function secret that I did mention this. So if you haven't checked out that video, please go and check out that video. Very, very important. Then we can have only 2 shapes for the gradient function, because the gradient function of the cubic graph is represented by the parabola graph. Now, we know that this one here is concave up. This is a concave up shape, which we know that most of the time it has the minimum value. And what you see here is the concave down shape, which most of the time has a maximum value. Now, I did say that the minimum or the maximum gradient will occur at this point here, which according to your parabola, you know it as the axis of symmetry, right? This is what we call the axis of symmetry. So the x coordinate. We are not focusing on the y coordinate, the x coordinate. The x coordinate at that point, using parabola language, we call it the axis of symmetry. But then using the cubic function language, we call it the point of inflection. So we haven't answered the question yet. I'm just trying to make you understand what is going on here. So the minimum gradient, it's occurring at -1 is to -7, which it happens to be the point of inflection. So number 1 is discovering that that point is actually the point of inflection, because the minimum or the maximum gradient always occurs at the point of inflection. Now, let's continue reading. They say, for which values of x will g be concave up? There we go. You will remember that I said whenever they mention concavity, concave up, concave down, then that thing has to relate to the point of inflection. And I just told you that the minimum gradient occurs at the point of inflection. And now they're asking you, for which values of x will g be concave up? They're asking you about the concavity. So point of inflection, concavity, there is always a relationship there. So that means the coordinates that you are given here are actually the coordinates of the point of inflection. This is something that you and I know as the participants of this channel here, which others don't know, right? As I told you, those are the secrets, right? So that's -1 is to -7, right? So that means at this point, for which values of x will g be concave up? We know that for for the same reason that they said this will be a minimum gradient, that means our G prime X will have to be a concave up graph. But if it is a concave graph, a concave up graph, what is the shape of our cubic function? The shape of our cubic function will now be like this, right? And this point that we are seeing here, which is at -1, when we put it here on the cubic function, right? That point is -1 is to -7, which indicates the point of inflection, the coordinates of the point of inflection. Now we know that at the point of inflection, the graph is not concave up, is not concave down, but that's the point where it changes concavity. So at this point, it's a matter of deciding, is it concave up after the point of inflection, or is it concave up before the point of inflection? Now, looking at the shape of this graph, we can see that right at this moment, going to that direction, we can see the cubic function is now starting to be what? Concave up. So our solution there is supposed to be when x is greater than -1, right? But then the question is, will I just get 4 marks from that? Will I just get 4 marks from just telling them that x is greater than -1? No. So this is how you're gonna put it out to them. Number one is you will tell them that a minimum gradient occurs at point of inflection. So the fact that this produces a minimum gradient, it tells you that your A must be greater than 0, right? If your A now is greater than 0, now this tells us that x is equals to -1 is your what you call your x coordinate of the point of inflection. And then you will have to draw these two shapes, right? So draw the shape for this one, indicating that you understand that when A is greater than 0, your G prime X is like this, but then your G of X is like that. Then show this coordinates over here and then tell them X is greater than -1. They will have to give you full marks for that because you've actually shown the whole process of how you got to this point here. Okay, so please press the thumbs up button, guys, if you have enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.